Hi, this is Professor Merrill Lichty. In this video we're going to look at problems involving sample proportions, and in order to answer questions about sample proportions we're going to need to know about the sampling distribution of sampling proportions. This turns out to be a very important concept in this course, and we're going to see it quite a bit, so pay attention and make sure you understand this one. Here's a sample problem to help us understand what's going on. Suppose that the population we're interested in is all U.S. voters, and that we know what the population proportion is for those who believe that marijuana should be legalized, and that proportion is 35% or 0.35. And we're going to take a sample of size 500. Now the question that we're asked here is, what's the probability that the sample proportion who think that marijuana should be legalized is within 2% or 0.02 of the population proportion? So let's review then the sample proportion. The sample proportion is P, and that's the proportion of the sample where we have a success, and we are saying a success in this case is somebody votes yes that marijuana should be legalized. Pi, of course, is the population proportion of those who say the proportion of successes in the population, and n is going to be our sample size. Well, we need to know what the distribution of P is, and it turns out that the mean of P, or mu sub P, is pi, same as the population proportion. And the standard deviation, also called the standard error of P, is simple to calculate. It's just the square root of pi times 1 minus pi divided by the sample size. What about the shape of the distribution? Well, it turns out that if n times pi and n times 1 minus pi are both greater than or equal to 5, then P is approximately normally distributed. And this is just another example of where the central limit theorem shows itself. And we saw that already with x bar under certain conditions, and now we're seeing that under certain conditions P is also normally distributed, and that will help us quite a bit. However, if the central limit theorem doesn't hold when we're dealing with proportions, we can always use the binomial random variable in order to calculate the probabilities that we're interested in. So we're going to solve the problem in 3 steps. First of all, we're going to check whether we have a normal distribution. And in this case, our sample size is 500, and so n times pi is 500 times 0.35, that's 175, and n times 1 minus pi is 500 times 0.65, which is 325. Both of those are greater than or equal to 5, so we're okay with using the normal distribution. Again, if these were not met, we could always use the binomial distribution. And we're not going to do that in this video. I'll refer you to the week 1 material for that. Step 2 is to calculate the mean and standard deviation for P. And we don't really have to calculate anything for the mean, just write it down. Mu sub P is equal to pi, which is 0.35. Standard deviation is equal to square root of pi times 1 minus pi over 500. And for this problem we have 0.0213, or about 2.1%. This third step then is to use what we know about the normal distribution and calculate the probabilities that we're interested in, because all we have now is a normal random variable with a mean of 0.35 and standard deviation of 0.0213. So this takes us back to what we did earlier in the course with the normal distribution. So what are we doing here? Again, the probability that the proportion who think marijuana should be legalized is within 0.02 of the population proportion. So we know the population proportion is 0.35, so we want to know the probability of being between 0.33 and 0.37, where we have basically this picture drawn here. 0.35 is the mean, 0.33 and 0.37 give us the bounds on the interval that we're interested in. So we have two ways that we can do this. The first one we would call the z-value approach, and that is to take the values 0.33 and 0.37 and convert them into z values. And we do that by getting 0.33 minus 0.35 divided by 0.0213, which is negative 0.94, and a symmetric version of that at positive 0.94. So now that we have the z value, where we can look up in the table in the book, or use Excel or Minitab to find the area. And the idea behind this is we see that 0.94 is our z value, and that has 0.8264% of the area to the left of it. And we want that part. We want that as part of our answer, but we don't want all of that. Instead, we have to find the probability of being less than negative 0.94, which is 0.1736. Again, look that up in the table in the book, or use Excel. The norm.s.dist function will give that to us, or I'll show you how to do it in Minitab in just a second. But the solution then is 0.6528, or 65.28% chance that the sample proportion will be within 0.02 units of the population value. And those units in this case are percentage points. Okay, so what about using Minitab to do this? We certainly can use Minitab. We'll come over here to Minitab. We'll go to Calc, probability distribution normal, and we're going to put in the mean. In this case, the mean is 0.35. Standard deviation 0.0213, and we want a cumulative probability. We're going to add up the area under the curve, and the input column, we don't have an input column. We could put one in if we like. That might make it easier actually, but we'll just go ahead and put input constant. We're going to put 0.37 first, 0.37, and now when we say OK, we get this output, 0.37. That's got 82.6126% of the area to the left of it. And we're going to do the same thing for the lower value. Norm, notice this is already pre-populated, so all I have to do is change from 0.37 to 0.33. And when we say OK, we see the 0.173874. So we get 0.8261 minus 0.1739, and we get 0.6522, which is very close to what we had with the z-value solution. However, the z-value solution came from the table, which is going to be less accurate, so the Minitab version is going to be what you want to go with. However, if you are answering a homework question or a quiz question, both of these should be okay. And that is how you deal with sample proportion probability questions.